All right, this is 5.10, the last unit in Unit 5, the last section in Unit 5. This is a Congruence in two-dimensional figures, Part 2, and this is real-world problem solving involving congruence. Very similar to the last one, which was Part 1. It just was more generic, but this one has real-world implications. Last time I pre-marked up the polygons. This time I'm gonna not pre-mark polygons so you guys can see the process in that, in case you didn't understand how I did that before. So we're gonna get right to it. Maybe I'll make some more space here in case I need it. So what I'm gonna do is I'm gonna work with all this over here. This is from the homework lesson, which I don't typically assign. You guys do the practice assignments, but these are from all different problems and questions that they ask, and these are givens in those questions, and this is the given like overarching statement, and this is the given overarching. This is accompanied with the given overarching statement. This statement right here was, and then these were all kind of speckled about, asking for specific things, and that's kind of how you're going to be asked those things. But I'm going to show you how to find everything, just working the polygons as the polygon set as a whole, given all different things. So the first thing is just like looking at it as a whole, and remember we had we pull out these two polygons here, and it says these are congruent polygons. So you just kind of that this one, pull this one out, that is congruent to this. I'm going to stack them. Helps you kind of see which letters match up with which letters a little bit. You just kind of have to, because the letters are different lengths. Stretch this but line up the letters. Okay, so now you can kind of see what line segments accompany which ones. So what I had done before is I took I'm gonna do this time to make it a little neater. I'm gonna say F Z D K B X, that's my K X L N. All right, now I'm gonna take these, zoom in a little, and here, yes. I'm gonna say, all right, so F is lined with G. These are congruent polygons, so what they matter which way you set them up. So F was G, Z is with M, Z is with M. Yeah, select it big enough that you can grab it. Z is with M. D is with K. D is with K. No, D is with H. D is with H. D is with H. D is with H. K is with C. Unstick. K is with C. R is with B. R is with B. W is with X. W is with X. P is with L. I'll have to just copy this one straight. P is with L. P is with L. And then N is with Y. So that I've matched up all my congruent points. All right, so that's going to help me kind of put less brain power into figuring out what is congruent to what down here. All right, so then I'm going to take some little pencils here and make sure it's bad enough so it sticks out. And VZ is congruent to XB. So VZ. So despite these being congruent up here, they're also congruent to other things. So VZ is congruent to XB. So that means that these are congruent. These share the same length, which means that these share the same length and these share the same length. Okay? Because these are congruent parts of congruent polygons, right? Because these are congruent. VZ is congruent and GM is congruent. Because XB is congruent, WR is congruent. XB is congruent, or BX is congruent, WR is congruent. Because they're congruent polygons. Yes, congruent polygons. Okay, for drawing shown with congruent polygons, this one and this one. So the order in which the letters line up matter. Like so, BX is congruent with BX is congruent with RW. That's why I kind of stacked it like that, so you can make sense out of it really easy. So that's why I can say that those two things are congruent. Okay, NL is congruent to BK. So this will be a double line, BK. Well, these lines are all the same. NL is with PY or YP, whatever way you want to look at it. YP. And so these lines are all the same. So those are all congruent. That's helpful to know. Okay. DZ, line segment DZ is congruent to KB. So DZ is this one. This will be the triple line. 2, 3. Of course, KB is that's a weak number 3 one. That's KB. And then KB is this one. 1, 2, 3. So which one is ZD's opposite? Well, ZD is right here. So it's 1, 2, 3. Which was KB's opposite? That's this one right here. 1, 2, and 3. 3 because congruent polygons. And these are the congruent segments of those congruent polygons. Cool. All right. And then, oh, these are all congruent too. That's congruent to LX. This is a transitive property. So these are congruent too. These are 3s. 1, 2, 3. And NF, which is 1, 2, 3, which means these are congruent as well. 1, 2, 3. 1, 2, 2. Should have just did the line tool. 2, 3. All right, so this is these 4 are all congruent. Right. So 1, 2, 3, 4 times 2, 1, 2, 3, 4, because these two polygons are congruent. Okay, and then the perimeter, the whole perimeter of this whole thing is 58 millimeters, 56.8 millimeters. So is this one 50? Man, I just type it. Get out of the way. Okay, so they're both 56 millimeters. Oh, these are sunglasses. I just realized that those are sunglasses. Okay, cool. All right, so now let's look at if there's anything we can like simplify down here. Yeah, I can simplify that. Distribute the 2. So this is going to become. Let's see. This is going to become 6x minus 2.8 times 2. Let's see, 2.8 times 2 is 5.6 minus 5.6. So minus 5.6. that a little smaller. And I'll do that. So I distributed 2 times 3 is 6x, 2 times 5 is 2 times 2.8 is 5.6. So I'm just gonna just get rid of this one and put this one in there for that. Well, I guess I can show my work. Ugh, ugh, sticky mouse bothering me. On my maybe my battery is going low in this thing. Oh, that's not select tool. Select tool. There we go. Select tool here. Move this guy over to here, next to it. There we go. That way it's simplified my math later. Okay, anything else I can put in there? Okay. So now I'm gonna just start dragging and dropping stuff. And I'm gonna do my line segments are gonna be on the outside, and they'll be I'm gonna pause this for a second and get another battery. Just a second. All right, that's much better. It was a battery issue. Okay, so where was I at? Yeah, okay, so we're gonna start populating this polygon with everything that we know based upon what's given. And we'll start with the line segments. There are not very many of those. All right, so we have PW. PW is over PW. PW is right here, and it's 6x minus 2.4. So I'll grab that. I'm just going to do make a red. 6x minus 2.4. Make this thing red. A little smaller. 18. Yeah, that should work. I'm gonna make it drop over here. So that is this line segment. Okay. And I have HC. HC is this little guy over here. And you know, every one of these little three hashes is everywhere else. Okay, so so this is the same as this, it's the same as this, and the same as that. So then I'm going to grab so HC is 6x plus or minus 5.6. So I'll do that again. 6x 6x minus 5.6. That one. Move it over to HC. There we go. Then we have WR. WR is this one right here. And it's going to be 5x plus 2. Make it red. Over here. Let's scooch that down a little. This is 5x plus 2. Okay. All right. So now do I know enough to figure this out? I sure do. All right, because I know the perimeter of all this stuff is, and this thing repeats itself a bunch. So what I'm going to do is I'll take this value, maybe move that a little too close. This value, control copy, control V. Where did that thing ended up getting? Oh, I spent it all the way over there. Hold on a second. So, well, you know, I'll just do this easier. Instead of like reposting all this all the time. All right, so how many of these three? I could do this a couple ways, right? I could copy this thing. My screen's a little bit. This is a TV that I use, so the resolution is kind of funny. So I guess I could do it like that, but it's not as nice for you guys. I don't like it like that. I'm gonna do this. Still want to do it like this. So I'm gonna show you this way. Last time I copied every single stop it. Every single line segment, and I just added it all together. I'm gonna do it algebraically a little different this time, since this one's a good opportunity to do it this way. Okay, so how you can see that I have 3. How many of these 3 notches do I have? I have 1, 2, 3, 4 of those. Okay, so I can say that I have four of the 6x x minus 2.4.4. Yep, and then how many of the single notches do I have? I have 2 of those. So I'm going to say, I'm going to add 2 of those. So it's going to be 2. I got 2 of those ones. 5x plus 2. All right. And then how many of the double notches do I have? I have 2 of those. So let's see. So I go plus 2 times 6x x minus 5.6. All right. And this is a perimeter, and it equals 56. 50, that's a 6. I'm getting ready to write 56.8 millimeters. Millimeters. Okay. All right, so let's double check to make sure I have all the different sides. I have 1, I count for that one, I count for that one. I have 2 of those. I have 2 of the ones. Check. All right, how many of the 2s do I have? I have 1 of the 2s. I have 2 of the 2s. Okay, I have 2 2s. Check. And those are 6x minus 5.6. And I have 4 of the 6x minus 2.4s. Got 1. These are the 3s. 1, 2, 3s. I got 1 of the 3s, 2 of the 3s, 3 of the 3s, and 4 of the 3s. Check. Okay, does everything have a dot on it? Yep, all of my sides are accounted for. So now I can just do some algebra here. Calculator to do some algebra. So 4 times 6 is 24. 24x minus, this is what I'm going to need the calculator from. So I do 4 times 2.4 equals, this is going to be minus 9.6. 9.6. Okay, now I'm going to go 2 times 5 is 10. 10x. 10x. And then plus 2, positive 2 times 2 is 4. Okay, and then I'm going to go over my next binomial. Positive 2 times 6 is 12x. 6x is 12x. And then positive 2 times negative something is going to be negative. So negative 2 times, calculator up. It's going to be like 11.2 or something. Let's double check that. So 2 times 5.6 is 11.2. 11.2 equals 56.8 millimeters. Okay. Now I'll just add up my stuffs real quick. Do all my x's. Real quick here. 24. I do this in colors. Okay, that's not the right color. Okay, I add all my variables. All my variable numbers. Include the sign when you box it off. And all of my non-variable numbers are going to be left outside the box. So 24 plus 10 is 34, plus 12 is going to be 36. I'm going to double check that with a calculator because I can. 4 plus 10 plus 12 is 46. Man, I'm glad I double checked that. All right, 46. 46. Go back to red. 46x. That's not red. 46x. 46x. Okay, I'll lock that in. And then this is all going to be equal to 56.8, by the way. 50, that's a 6 again. 56.8. All right, now we got to add up our negatives. I'm going to start with -6. That's my starting point. So -6. How do I do negative on this thing? Oop, that's not right. Well, there it is. 9.6, make it negative. So I started with 9.6 in the negative direction, negative 9.6 plus 4 minus 11.2 minus 11.2 equals negative minus, how would it go? Where'd it go? Minus 16.8, negative 16.8. 0.8. Let's add that to both sides to get rid of it. All right, so 56.8. $73. So 46 x equals 73.6. And now I just got to divide that. X equals divide 7.6 by 46. Divide that by 46. That gives me 1.6. I'm going to pause the video to check to see if my algebra was right before I move on. And then I will move on. Standing by to pause it. Okay, so I actually got that one right for once. Took my time, so that one's correct. X equals 1.6. I'm going to slide that up there. Take a screenshot of that math if you like. I'm going to delete it in 5, 4, 3, 2, 1. Got it. Okay, so X equals 1.6. Okay, so that pretty much gives me everything I need to know about every perimeter and every line segment here. So I don't think I'm going to be needing to solve for any of these line segments. Maybe I do. Why not? Okay, so let me go ahead and plug 1.6 in for all the x values here. So I'll bring up this. I'll slide this over to help solve it and put my calculator up right here so you can see both at the same time. All right, so let me clear this and do 6 times 1.6 minus 5.6, and this equals 4. So all my single or my double slash ones equals, I'm gonna change this to like, yeah, I'll just format it, I guess. All these, it's 4. All my double slashes, let's do this, equals 4. I'll just write on top. I'll delete them. That equals 4. And that equals 4. All right, that was, what was 1 again? It was 1.6. Okay, yeah. So 5x 5 times 1.6 equals plus 2. This equals 10. This now is 10. Every single slash on here is 10. And triple slashes 6x. No, I probably should do the math before that. All right, so 6x 6 times 1.6. 0.6, right? Yeah, 1.6 equals plus 2.4. Hit a nice round numbers. It was 12. So this one is 12 here. This one here is 12. 1.6 seemed pretty suspect, but now it's all coming together. All right, so there we go. There is all the side lengths that you need. I'm not going to duplicate it for all the different ones because that would be silly. Just know that each triple slash is 12, each single slash is 10, and each double slash is 4. Okay, so here we go for the angles. Take a breather on that one. So we don't need this one anymore. We don't need this one anymore. Don't need that one anymore. Now we have to start copying all these other angles. I'm going to do the angles in light blue. And we got M, or measure of BLX. BLX. BXL. BXL is 4K. K minus 8. Check. We got DZF. DZF is 3K plus 25 plus 3 is 3K plus 25. 25. We got XLN. XLN. This guy is 5K. 5K minus 19. It's like we're using this side for angles. This side was going to be for measurements of the sides. And then XBK, this side here is the XBK. This is driving me crazy. My X's, my K's. XBK is 5K minus 41. I don't know what it is with me and X's and K's, but it drives me crazy. I can't read that. 5K minus 41. There we go. Got that one. Yeah. DZF. DZF. I already did that one. Didn't mark it off. Did that one too. Didn't mark it off. Okay, then we have some congruity statements. Sorry. NZF. Where is it? NFZ. NFZ. Single arc here. NFZ is congruent to DZF. DZF. So these are congruent. That's cool. Right. And then BKB. BKB. This guy is 3K. Maybe move this down more. DKB is 3x plus 47, 3k, k plus 47. Okay. XLN is congruent, double arc, congruent to LNF. L, and these guys here are congruent. That's cool. and then d zdk, zdk, zdk is, or measure of zdk equals zdf. I shouldn't do that. This is equal to zdf. This equals zdf zdk k plus 22. I got a feeling that that's gonna be needing zdk. Right, that's, and then we have this last one, that this angle, that this one is zdf and nzf, where's nzf? Okay, nzf, just do a dot, fz, fzd. Let's see fzd up here. F, I don't have an fzd, or fzd up here. That's this congruent one, which is fcd of 3x 3, yeah, 3k plus 25. Where'd that go? DFC. No, that's the same thing. That was tricky. Sons of guns. Okay, so it's this one, this one. Aha. See what happens when we mark these up. We find a little tricky. Okay. And then MHC. And then MHC is MHC. Maybe they did it again on us. Oh, MHC. MHC. So which was an MHC congruent to? It's the same thing as F is the G. So this is the same as the double one. They're congruent. So this one, okay. I think I might see a starting point here, everybody. Okay, so what is DZF? What's DZF? DZF. Haha, I know NZF. NZF. What is NZF? NFC, NFZ. NFZ is congruent to DZF. DZF. Okay, so these are all 3K plus 25. Okay, because so the measure, because the measure of NZF is congruent to the measure of DZF, and DZF is 3x plus 25, this can get substituted for 3K plus 25. That's the first term. Okay, so this is now 3K plus 25. Because this is this. Okay, that's the transitive property of equality. Okay, then you have MFZD. FZD is clearly stated as 3x plus 25. FZD is FZD. Okay, so that is plus 3K plus 25. And then you have MHC. And MHC is the same as, oh, maybe I misread that. MHC is the same as ZDK. And ZDK This should say DZF plus 22. Let's say DZF. This is ZDK. It's just be DZF. DZF plus 22. Okay, so we might have to find a measure of DZF first. So, okay, so let's see. All right, so measure of MHC. MHC is the same as the measure of ZDK. ZDK is plus a measure of angle DZF. DZF plus 22. That equals, that all equal, whoops, that all, whoops, that all equals, that whole thing equals 394. 394. So I still have one variable I have to account for before I use this. So I got to find a measure of angle DZF first. So where is DZF? DZF is 325, is 3K plus 25. Okay, so maybe I don't have to do all this stuff anyway. So 3K plus 25, 3K plus 25. So I need to figure out if this thing is congruent to something else on here. I'm gonna pause and think about it for a second while you guys are don't recognize that I'm pausing it. Yeah, so I actually have it right here. I just have to take this value here. This is measure of DZF. DZF. I have it in terms of K. I just need to plop it in there. Right there. So I'm just gonna take that. Can't believe I didn't see that right ahead. I was substitution exhausted. I didn't see it until just now. Right, so I take that in there, squeeze that together, and now I can solve for all that stuff. So I got 1, 2, 3 times 3K, that's 9K. All right, so I have 9K, 9K, 25, 50, 75 plus 22. 25, 75 plus 22. Brain's dead right now. 75 plus 22 is 97 plus 97 equals 394. 394. So then we can say 9K equals 394 minus 97 equals 297. 297. K is going to be equal to, whoop, what's that button? Divide that by 9. 33, that's nice, nice round number. Okay, 33. All right, so now I just kind of plop in K for all values that I don't know. Now, delete this at 5, 4, 3. I'll leave up there. Okay, so now I'm gonna slide these. I'm gonna move this over here. That's a good spot for it, so I can do this. Yeah, there we go. So now I'm just gonna go ahead and put in everything that I know right here and start plopping in 33 for K's in there. So we got 33 times 3 plus 25. So these are 124s. this is now this is now 124. 4. This is 124. This is going to be 124 plus 22. Be 146. Six. 6. Okay. Then we have, I bet this is the same value. So we'll see. Okay, then we're going to clear this. We're going to go 3 times 33. That's 99. We're going to add 47 to it. That's one. Oops, that multiplied. E times 46. 3 times 33 plus 46 equals 145. Oh, wait a minute. That's not right. It's 47. So it's 146. One 146. Yep, just as I presumed. Okay, then we have 5K minus, is that 41? That's what is that? 5K minus 41. Yep. So it's going to be 5 times 33 minus 41, 124. One 24, right? Good enough. Starter. Start. Okay, I got it. Okay. Now I got 4x. 4x. 4 times 33 minus 8. That's 124. Hey, those are congruent. That's cool. Hey, these work. That's nifty. All right, then we have 5x minus 19. 5 times 14 equals minus 19 equals 51. That doesn't look like a 51-degree angle to me. I'm doing that again. I think I put the right numbers in there. 5 times 33. That's more better. Minus 19 equals 146. That's more better. Okay. Hopefully that I got the right stuff. There we go. And that's 146. 146. That looks like nice round looking numbers for this polygon here. It's like a hexagon kind of. All right. So there you go. That's all my size and all of my angles. And that's how you do it. So my biggest little hiccup there is not realizing that I could have dropped this value in for this. Where to go for this value right away? Right. So keep an eye out for those little tips and tricks there. When one value is equal to another value, when you have, that this value is here, right? That was an easy substitution that I just missed. I could have been like right away. I could have been like, hey, let me just do this real quick. Whoa, I should have done that. Return to the gray. Could have been just like, hey, let me just do this real quick. Avoided all that confusion. I could have like slide that over a little bit and then been like, bingo bango, I'm done. And then that would have solved that right away. And I wouldn't have had that little pause to figure out what had happened. That took me about 3 minute pause to figure out what I had to do there. But aside from that, that was a pretty smooth problem. You just gotta, approach it logically. Labeling is your friend. Color coding can be your best friend. Okay. If you just try to like keep all this stuff stored in your memory, you'll lose your mind and you'll make mistakes. So I made mistakes even when I was organized. So hopefully you learned from mine and this helps you out in the future.